I redid a little bit of the notes from yesterday, so I printed different ones, otherwise I think it would have been a little confusing, so I'll hand out new ones. And then we have a worksheet today. It's right over here now. So, just so you know, next week, I think we only have like, I think I have it right here. We have new stuff today and Monday, and then on Tuesday already, you're gonna have a practice test and Wednesday a test, and then we'll be done with chapter 1. So just so you're aware of that. Today, what we're gonna do is exactly what we did yesterday, except yesterday we graphed the 2 lines to see if they intersect, if they're the same line, or if they're parallel lines. And you can do that algebraically also. The thing that this has in like a pro to this way is that it works for any answer. So graphing really only works if you have a coordinate pair where they intersect, where both are whole numbers. Otherwise, you'd have to estimate. The other way that graphing can work, and I didn't show this to you yesterday, is if you have 2 lines solved for y, you can do it on your graphing calculator and see where they intersect. And then that too can be when you have decimals and things like that. You'll have to get one for you. So today's way just works all of the time. Okay, so we're gonna learn 2 different ways. One is called substitution. Personally, I like the second way I show you better, but it's up to you. When substitute, Chris, you'll have to go right now. Yeah. So, with substitution, what happens is you look at your equations, and the only way I'd ever do substitution is if one of my variables did not have a number in front of it. Okay, so if you notice here that x is by itself, it doesn't have a number in front of it. So if you are going to use substitution, I'd start with that equation. So what you do is you start with an equation where one of the variables just really has a 1 in front of it. Adam, you need to put your MacBook away. And then what we would do here is we would take this and we'd solve it for x. Okay, so we're going to take this equation, bring the 7y over by adding 7y. And then we'd get x equals, and you know, before I always told you to put the variable in front. That's only when you're doing slope-intercept form. So here you could, but you don't have to. You can just go 11 plus 7y. So what we've done is we've taken that first equation, we've solved it for x. So now what we're going to do is we're going to take our second equation, which is the 5x plus 4y equals negative 23. Okay, and we're going to take this expression for x and we're gonna substitute it into that second equation where x is. So now we have 5 times x is 11 plus 7y, and then plus 4y. So what I did is I put this in for x, and because there was that 5 in front, I had to put it in parentheses so that I knew to multiply 5 by both of these. Then I just copy down plus 4y, and it equals negative 23. Okay. So if I look here, we would distribute the 5. 5 times 11 is 55. 5 times 7y is 35y. And then we'd have plus 4y equals negative 23. Okay, thank you. So then we just keep solving for y. So what I would do next is I'd add my two y's together. 35y plus 4y, you're just combining like terms. So 35 plus 4 is 39y. And then I still have that plus 55, and it equals negative 23. Then what I would do is subtract 55, and I'd get 39y equals, and here when I do negative 23 minus 55, it's negative 78. Okay. And then I would just divide by 39. And y is a negative 2. So what that tells us is in our coordinate plane or coordinate point, y is negative 2. So then what I'm going to do is I have to go back up to this expression and put that negative 2 in for y. So if I have x equals 11 plus 7y, again, I'm going to take this negative 2 and put it in here for y. So it'd be x equals 11 plus 7 times negative 2, which is 11. 7 times negative 2 is minus 14, which is a negative 3. So now your final answer, you would write that point as an ordered pair. So x is negative 3, y is negative 2. And this is your answer. Now, if you were on the test, you could check this. If it's negative 3, negative 2, you could put those back in here and see if it works. So x was negative 3. And then you can check, is negative 7 times a negative 2 going to be equal to 11? Well, this is negative 3. This is plus 14. Negative 3 plus 14 is 11. Okay. All right. So now that is one way that you can do this. And like I said, there's nothing wrong with doing it. I kind of think it's a little more work, but there are times you can't really do it without using a lot of fractions. And that's if there was like a number 3 in front of here, then it would be hard to do substitution because you'd have fractions. And we typically don't like to use fractions if we can help it. So if I look at this one, the second way that I'm going to show you today, some books call it linear combinations. Some books call it elimination. Okay, so I'll go through the steps with you on the next page, but these are the actual rules. And then today, you can also have all 3 situations. So the one we just did was where we had 2 points that intersect, and we found that actual intersection point, and we had it as an ordered pair. The second thing that can happen today is we can get parallel lines, and how we would be able to tell that today is you would get a situation like this, I don't want to say too much yet, but your variables would cross out and you'd have a number on each side of the equation that are not the same. Okay. And then the last, if that happens when they're parallel, remember from yesterday, it's no solution. And then the last thing that can happen today is both lines can be the same line and then they really intersect in every single point. So that's infinitely many solutions. And how we're going to be able to tell that today is our variables are going to cross out and we're going to have something on each side of the equation that are not equal. Or I'm sorry, that are equal. Here's where they're not equal. Here's where they are. Okay. So if we go to this page, I'm going to show you using linear combinations. And this is something you did in Algebra 1, so I think you probably remember this. Oops. So here's what happens. I like to call this way elimination better than linear combinations, because what you're trying to do is you're trying to eliminate your x's or eliminate your y's. And what you would basically think of there is, would it be easier to multiply one of these equations by some number so I could get rid of my y's or my x's? Okay. For your y's, if this is negative 3y, I would just need to get this one to be plus 3y. And how I would do that is I'd multiply this whole bottom equation by a positive 3. Okay, when you do that, this is super important. You have to multiply that 3 by the 2x. You have to multiply it by the y and the 7. So when I go 3 times 2x, that's 6x. 3 times y is 3y. And 3 times 7 is 21. Make sure you are multiplying the 3 by all 3 terms. Okay. Then what I do is I take my other one that I didn't change and I put it right underneath this one. Okay. For linear combinations, you want your x's to line up, your y's to line up, and your numbers to line up. Okay. And then what you do, once you get one set of variables like plus 3y and negative 3y, you think of it as you're adding going down. So 6x plus 5x is 11x. Do you guys get that a positive 3y and a negative 3y are going to cancel out? So these are gone. And then 21 plus 23 is 44. Now you go ahead and solve that. So divide by 11 and x is 4. Now, if it was one of those special cases, what would happen is both of your variables would cancel. Okay. Now what I'm going to do, I know what my x is, but I still need to find out what my y is. So I'm going to take one of these two equations. It doesn't matter. I would probably choose this bottom one just because it has smaller numbers and there's nothing in front of the y, but you can do either one. And you're going to take this x and you're going to put it in there and then solve for y. So you're going to go 2 times 4 plus y equals 7. And then 8 plus y is 7. And then you're going to subtract 8. And y is negative 1. Okay. Final, what you do is you write this as an ordered pair. So this is 4, this is negative 1. And what that means is if you graphed both of those lines, they would intersect at this point. And you could put those back in, you know, to multiply this by 4, multiply that by a negative 1 and see if it's equal to 23 if you wanted to check it. All right, so if we look at example 10, the first thing we want to do is decide which of our variables do we want to get rid of? Do we want to get rid of our x's or our y's? And it doesn't matter, okay? This one looks a lot like the one up there where this is a negative 3y. So if I could get this to be a plus 3y, then my y's would cancel again. So I want to multiply this by 3. Okay. 3 times the negative 3x is negative 9x. You multiply the 3 by all of the terms, even the negative 5. So 3 times y is 3y. 3 times the negative 5 is negative 15. Then I'm just going to take this one and write it below. So 9x minus 3y equals 15. Okay, draw your line and you add going down. Okay, notice your y's cancel. What do you think happens to your x's? They cancel also. So basically what we're left with on this side is 0 because nothing is there. And what's negative 15 plus 15? 0. When you have 0 equals 0, then it's infinitely many solutions. And what that means is that your two lines are the same exact line if you graph them. So the ones that are infinitely many solutions or no solution are actually a little quicker to do. Okay. So if we go here, let's look at this one. So this one has, and by the way, if I decided to get rid of my x's and you decided to get rid of your y's, as long as we both do the same math, we'll get the same answer. With 3 and 4, you would have to multiply both equations by a number. What you would think about is what do 3 and 4 go into? And they both go into 12. So you'd have to multiply the top equation by a negative 4 to get negative 12. You'd have to multiply the bottom equation by 3 to get a positive 12. This one for 10y and 5y, you'd only have to multiply one of the equations because 5 and 10 both go into 10. So do you guys get if I'm trying to get rid of my y's, what would I multiply the top 5? And would I do a positive or a negative? Negative 2. Very good. Negative 2 times 3x is negative 6x. Negative 2 times 5y is negative 2y. Negative 2 times negative 27 is 54. Then I'm going to take this and put it right underneath. And then I'm going to add going down. Okay. Negative 6x plus 4x is negative 2x. 54 minus 46 is going to be 8. Divide by negative 2. And x is negative 4. So this is not one of those special cases. And then what we would do is take one of these and put it over here and substitute in. And in this case, it probably really doesn't matter. I think I'm going to do the 3x plus 5y equals negative 27. And I'm going to put this negative 4 in here. Okay, so we have 3 times a negative 4 plus 5y equals negative 27. Okay. 3 times negative 4 is negative 12, plus 5y is negative 27. Then I'm going to add 12. And I get 5y equals negative 15. Divide by 5. And y is a negative 3. And again, when you write your answer, you're going to write your answer as an ordered pair. Okay. Let me just check here. For the regular ones, do you think you need to see more of those, or do you get how to do the ones where it ends up as an ordered pair? Want to see one more like that? Okay, everybody get that? Fine, okay. So we're gonna skip this one down here. Let's go to the back page. And again, there's three possibilities. One is going to be where you get a point where the two lines intersect. One, what's gonna happen is you're gonna get something like this. You would get 0, both your variables would cross out, but your numbers would not cross out. So you'd get like 0 equals -12. If 0 equals something else, it's going to be parallel lines and no solution. If it's where all three things cross out, your x's, your y's, and your numbers, then it's infinitely many, and that's just one straight line. Okay, so let's do A. And you can either think of this as trying to get rid of your x's or your y's. Let's see if I did the same one before. I did. So let's go down to this one. We'll go into this one. So you're going to ask yourself, do you want to get rid of your x's or do you want to get rid of your y's? So I'm going to take this bottom and I'm going to try to get rid of my x's. Right now, this is -1x, and I want it to be -2x. So I'm going to multiply that by 2. So 2 times the -x is -2x. 2 times 6y is 12y. And 2 times -9 is -18. Okay. Then I'm just going to bring the other one down and put it right below it. 2x minus 12y equals 3. Okay. Now, notice these cancel as well as these. So that means you have 0. And then -18 plus 3 is -15. So this is one, again, if it's 0 equals 0, it's infinitely many solutions. If it's 0 equals any other number, then it's no solution. So what do you guys think? Do you want to see another one, or how do you feel? Good? Feel good? Okay. So I am going to give you guys a worksheet and you will work on that. I believe you should get full or whole numbers for the points. If you don't, then you're doing something wrong. Okay. And I am doing grades right now for homework, so if there's anything you need to turn in, make sure I get that. Yes, you actually would have to multiply that top one by.
But then I did that and I got. I said that there's no points because this equals 10 and you can't divide 4 by 10.
This would be -10, then right, and -2. Y, and you add going down.
Or so you don't subtract it out.
Yeah, so it was -10 plus 4 would be -6.
Oh.
Does that make sense?
But this is a bar square.
Is this yesterday's? You want to staple that? There's a stapler right there.
Let me start.
Yeah, the first one, you guys, is a little bit hard. You could multiply the top equation by a -1, and that would give you a -y and a positive y. That's probably what I would do. I try to eliminate my y's, and because each of them is plus, I try to just multiply one equation by a negative. So if you do this top by a negative times a negative is positive, -1 times y is -y, -1 times 5 is -5. Does that make sense? And then your y's cancel.
I don't know if this one's for me.
Or are these two different equations, two different assignments? Okay. Okay, do you want to figure out what page numbers that one is and put it on the top?
I was gone yesterday and I was just wondering, how do you find the number that you multiply one of the equations by?
So this is what we did today.
Mhm.
So this was the one I was saying, I would try to get rid of my y's. So if this is plus y, that would have to be a negative y. So you'd multiply all of these by y,
Sure.
or -1. -1 times -x is x. -1 times y is -y. -1 times 5 is -5.
Oh, okay.
And then these cancel. Positive y minus y, -2x plus x is -x, and 4 minus 5 is a -1. Then you divide by -1, and y is a +1, or x is a +1.
Okay.
And then you're going to substitute that back into one of these two and solve for y.
Okay.
Okay?
Yeah, okay.
And then let me give you yesterday. And you need graph paper for yesterday. You know how to watch the video?
I figured it out.
Let me just show you. Okay, thank you. If you go on to Algebra 2.
Yeah.
And you go to these weekly snapshots. And yesterday was week 2, Thursday. So if you go down there, these are just notes, but here's the worksheet we did yesterday, which I'll have to give you. And this is the video, so you'd want to watch that.
Okay.
Because yesterday's was graphing, and so I'll grab you the worksheet.
Sure.
There you are.
I have a question for, is this already?